Welcome back. We are now at a point in time where this is a new section, volume by shells. This is something we did not cover in AB. We just did volume by discs and volume by washers. We did not do by shells. And so that's what we're going to be covering today. What a shell is, it's basically a cylinder taking the outside, the surface area of a cylinder, not including the sides of the top and bottom. So like if you took your soup can, okay, and you took your soup can and you only found the outside edge. So the top circle here and this bottom circle are not included. You only care about the outside, like that. If I lay it out, right, that creates a rectangle. And that rectangle here is going to be the area, which is 2 pi RH. So remember, surface area of a cylinder, okay, is 2 pi r squared plus 2 pi RH. We're taking out the formula, the 2 pi r squared, for the circles. Like, we don't care about the top and bottom of a cylinder. We care about just the flat surface that we could lay flat if we were to actually put it in terms of a rectangle. But this is what we're going to be focusing on, 2 pi RH. And the reason we use the shell method is when we have functions that look like this over here, y equals x to the third plus 2x squared minus 4x. Solving this for x equals is going to be really hard. And because it's really hard, I have to use the shell method. Now, if you are in higher level mathematics or using computer programming, MATLAB, or MATLAB, I don't remember what it's called, or Mathematica, you could definitely use that program to find and iterate what to be x equals, okay? And it would very easily do that. But it would be some crazy long function, and then you don't really want to integrate all that garbage. So using the shell method actually makes it easier so that you don't have to find out a crazy mess to integrate, okay? So what is the shell method exactly? The shell method, using different types of axis. Okay, the horizontal axis, this is basically if you're rotating it over the x-axis. So the x-axis of revolution or the y-axis of revolution. Y-axis, oh my gosh, y-axis, there we go. Okay, so y-axis and x-axis. And what happens is these are going to be kind of backwards based on what we've done with disk and washer. I have to find the radius and the height of the function. So in this case, the radius is from the function down to the x-axis. Okay, x-axis of revolution, x-axis here. Okay, and we're going to take this function, we're rotating it that way. Okay, but it's going to be some crazy function that we won't be able to find a good value. So that's the radius from the function down to the x-axis. Then I have to find the height of the function. So how long is it? Okay, or what is this value going to be? Okay, so if the function is, from here to here, I can easily figure out that's going to be the x. That's going to be like our change in x. Okay, and then because it's a shell method, and like I said, it's opposite, instead of our bounds going from whatever this bound is to this bound, we have to take and go vertical bounds, so C to D. So the horizontal axis, which is the x-axis of revolution, has bounds that are on the y-axis. It's a little confusing. The vertical axis of revolution, we're doing the same thing. We're taking the function, and from the function to the y-axis is our radius. The height is whatever that height is of the function, but then our bounds are going to be on the x-axis from A to B. It's flipped. They are flipped on the shell method versus the disk or washer method. So we have to understand and remember. Okay, we got to think about that. So let's get into some examples. First example, here we go. Find the volume of the solid revolution formed by revolving the region bounded by y equals x minus x to the third. The x-axis, the y-axis, and x equals 1 in about the y-axis. So we're going about the y-axis, okay? So that means we're doing a vertical axis of revolution. Okay, vertical axis of revolution. All right? So, what do we want to do? We want to do. I'm just kidding. I'm just scrolling up just to kind of waste more time. So let's draw the function first. Okay, so here's our function. We can see that x minus x to the third, if I actually solve that for 0, x times 1 minus x squared equals 0. I get x to be 0, -1, and +1. But because we're bounded by this axis, which is what we're rotating around, then I have to stop there. So this function is going to look like this, okay, from 0 to 1. And it would actually come down over here. It would actually look like this, and this would be a positive, or be -1. But I don't care about that, right? Because I'm not in the negative realm of this piece of graph. So I need to find out the height because I'm rotating around the y-axis. Okay, the y-axis, which is right here. I need to find the height. I'm sorry, which is right here. Vertical axis of revolution. I need to find the height. How tall is it? Well, how tall is it is basically going to be from here to here. Okay? Because I'm rotating around that, this is our h of x. And therefore, this piece here is going to be our r of x. It's our radius. All right? So what is our h of x? Well, that's the function. Our h of x is going to be x minus x to the third. X minus x to the third. So we can say the volume is 2 pi. That's our constant, right? I can scroll up and see that the 2 pi is out front. And because we're revolving it around the y-axis, I choose the values on my x-axis, my bounds. So that's from 0 to 1. 0 to 1. What's the height? Well, we know the height is x minus x to the third. But what's the radius? That doesn't really make any sense. Well, if I think about this, no matter where I place a dot or a point or whatever I make that cylinder, that's always going to be the x value. That's always the x value. So from this line to here is always the distance of x. So that r of x is always going to be x in this case. And now I have to multiply it by dx. And when I do that, I'm probably, if you're going to do it longhand, you're probably going to multiply out and say this is really 2x minus, I'm sorry, not 2x, x squared minus x to the 4 dx. And then you do it longhand, and you're going to get somewhere around 0.2667 pi. That thing is 0.26 repeated, but something like that. Okay, that's what you're going to get there. Next one. Find the volume of a solid revolution formed by revolving the region about that crazy region. The x-axis, the y-axis, and y equals 1 about the x-axis. So this one, we're going to try to draw this one. It's going to look really weird, but that is okay. So let's go x and y-axis here. The function, we know it's bounded by y equals 1. So we're going to say, okay, this is y equals 1. It is bounded by the x-axis and the y-axis, so right there. And the function is going to look kind of like this. Well, maybe not like that. Maybe like that. Okay? Where it's going to now be rotated around this axis. Well, what's the height of the function? This is 0 and this is 1. Okay? Because it's around the x-axis, we go back up here, that means we're going to find 2 pi. Our values are going to be on the y-axis, and I'm needing to find the radius and the height of the function. So the height of the function, okay, is going to be because we're on the horizontal axis, or the x-axis here, the h of x is going to go from right to left, and then the r of x is going to go top to bottom. So h of x is the height. So from here to here, well, that's just the function. That's just the function, which is e to that negative y squared piece. And then our radius is going to go here from top to bottom. Okay, our radius is going to go there. Well, in this case, what is our radius? Well, I guess this would be h of y and r of y because of how we're writing the function. So this would be h of y and r of... No, that'd be right. I'm dumb. I'm dumb. It's right. I'm right. I'm right. Okay, so what does this mean? R of x actually mean? Well, no matter where I am on this piece of the graph, I'm always going to be at the value of y. So this is always y if I want to find the value down. So that's our y. So r of x is our y value. So the volume is equal to 2 pi times the integral, because it's about the x-axis, and I have to use my y bounds, so from 0 to 1, of the height, which is our function, e to the negative y squared. Our radius is our y, and that's dy. And you can solve this by u substitution and say u is equal to negative y squared, and then du is equal to negative 2y dy, and you could then cancel out that, bring out the negative 2, right? So you would get the volume is equal to negative pi times 0 to 1. Actually, I'm going to take away the 0 to 1 because I didn't change the bounds, of e to the u du. And then you integrate this, so this would be from negative pi e to the negative y squared from 0 to 1. And that would be what you get, which is around 0.632 pi. Okay? It's a little confusing. We got to kind of do the work. We got to understand it. We got one more to go. Let's go. One more to go. This one's a little bit doozy because it's a little more difficult. It's not going to be around the x or y axis. It's going to be around the line x equals 2. So it's going to be a little bit, we got to think about this one. It's a thinker. Okay, so let's draw this function. So let's see. This is the graph. Y equals 1, x equals 1. Okay, y equals 1. So y equals 1 is a line. That's a little bit too high. I guess I don't like that being that high. So let's go y equals 1 here. Let's go over here. Y equals 1. X equals 1 is going to be, say, right in here. Okay. And what does the graph actually do? Well, the graph from right here to, and they actually intersect at 4. If you plug in x equals 1, you get 1. Actually, they intersect at 3, don't they? Or did I do my math wrong? No, I did my math right. Sorry. So this is at 3. So this function is going to go look kind of like this coming up. So this is at 3. That's at 1. So 1 to 3 on that axis there. Okay. Now, what else do we have? We have x equals 2 as our line. So this line way over here is what we're actually rotating the function around. So this little piece, kind of this little piece in here, is what we're going to rotate it around. So very similar to the disk and washer method, where I have to subtract off the axis of revolution. Or actually, in this case, it's the axis of revolution minus the function. Okay, because it's furthermost to the right. All right, so what I have to do is this. Because x equals 2 is a vertical line, and I'm rotating around a vertical line. Not very smart today. Sorry. 10 o'clock now. This is what I'm going to do. So the vertical axis of revolution, this is how I'm going to approach it right here. So I have the h of x, which is our vertical height, and our r of x, which is our, I guess, horizontal r of x. Okay. So I have my h of x, which is right in here. To find out what that is, that's h of x. Our r of x is all the way from here, because that's our axis of revolution. Okay, so our r of x is all the way over there. All right, so because this is a vertical axis, like shell method here, I have to use the values on the x-axis. So 0 to 1. Okay, 0 to 1. So the volume is equal to 2 pi times the integral from 0 to 1. Now, what is my h and what is my r? Well, my h is just the function. Okay? It's just the function, but what do I got to do? Well, I'm actually subtracting off the line that it's supposed to rotate kind of around, right? That y equals 1, I have to subtract it off, because otherwise, if I don't subtract off that 1, it's going to do all the volume like all of this area all the way down to the x-axis, and I don't want to do that. So h of x is equal to the function minus what that line is, y equals 1, which is x to the third plus x, right? The ones are going to cancel. So this is our h of x, x to the third plus x. Well, what's our r of x? Our r of x is also going to be a little bit more difficult, because this piece here, okay, if I find this value of x, which is what we've done, I have to subtract off the axis of revolution, which is 2. So it's 2 minus x in this case. No matter where the r is, wherever the radius is, it's always going to be x. But 2 minus x gives me every one of those pieces inside that big piece. So I get the radius is 2 minus x. Now I have that dx, and I can very easily, again, multiply it out if you want to, plug it in your calculator, do all your stuff, but you're going to get around 1.9333 repeated pi. Okay, that's it for this video. Hopefully this makes a little bit of sense. It probably doesn't. It's a little bit complicated. It's kind of backwards thinking based on what we've done. But we're almost done with this unit. Next unit, or the next section, is also brand new. It's arc length in area or sector, something like that. And so we'll get to that when I guess we'll see you in the next video. Deuces.